The James Webb Space Telescope discovers enormous distant galaxies that should not exist. Giant, mature galaxies seem to have filled the universe shortly after the Big Bang, and astronomers are puzzled. Nobody expected them. They were not supposed to be there. And now, nobody can explain how they had formed. Galaxies nearly as massive as the Milky Way and full of mature red stars seem to be dispersed in deep field images obtained by the James Webb Space Telescope, Webb or JWST, during its early observation campaign, and they are giving astronomers a headache. These galaxies, described in a new study based on Webb's first data release, are so far away that they appear only as tiny reddish dots to the powerful telescope. By analyzing the light emitted by these galaxies, astronomers established that they were viewing them in our universe's infancy only 500 to 700 million years after the Big Bang. Such early galaxies are not in themselves surprising. Astronomers expected that first star clusters sprung up shortly after the universe moved out of the so-called Dark Ages, the first 400 million years of its existence when only a thick fog of hydrogen atoms permeated space. But the galaxies found in the Webb images appeared shockingly big, and the stars in them too old. The new findings are in conflict with existing ideas of how the universe looked and evolved in its early years, and don't match earlier observations made by Webb's less powerful predecessor, the Hubble Space Telescope. We had specific expectations for the type of galaxies that live in the early universe. They are young and small, Joel Leha, assistant professor of astronomy and astrophysics at Penn State and one of the authors of the study, told Space.com in an email. Previous studies of the early universe with Hubble and other instruments tend to find small, blue, baby galaxies at early times, objects which have just recently formed out of the primordial cosmic soup and are themselves building their early stars and structures. Young stars in general shine bright blue. With age, stars develop a redder glow as they burn through their fuel and cool down. In ancient galaxies that Webb was built to spot, astronomers had not expected to see old red stars. They also had not expected to find galaxies more massive than perhaps a billion suns. But those reddish dots revealed in Webb's deep fields appear 50 times more massive than that, Leha said. The most massive galaxies in our sample are estimated to have masses 2 to 4 times lower than that of our own Milky Way, Leha wrote. This was astounding. We're finding galaxy candidates as massive as our own galaxy when the universe was 3% of its current age. Leha said that before astronomers start rewriting cosmology theories to explain how these galaxies came together so quickly after the Big Bang, they will have to ensure the odd red dots they are looking at are not something else. Most of the alternative explanations, however, also require entirely new concepts, Leha said. The exploration and study of the universe and its many complexities have been a source of inspiration and fascination for generations. As we push the boundaries of technology and science, we discover new and exciting things that challenge our understanding of the universe. One such area of study is the formation of stars, particularly in the early universe. According to Emily Leha, an astrophysicist at the University of Arizona, our current understanding of star formation in the early universe may be flawed. There are many factors to take into consideration when studying the formation and evolution of stars, such as the presence or lack of heavy elements, the mass of the stars, and the interstellar medium. However, Leha believes that our models may not fully incorporate all of these factors, leading to a lack of understanding of how stars formed in the early universe. For example, stars in the early universe might emit light in exotic ways due to their lack of heavy elements. This lack of heavy elements would change the way the star emits light, which could impact our understanding of the early universe. While we have models that take into account the impact of heavy elements on star formation and evolution, these models may not be accurate when studying the early universe. Another possibility is that our understanding of how stars form in the local universe is not applicable in the early universe. gas plays a crucial role in star formation, and how many stars form from gas is dependent on the mass of the stars. However, this relationship may not be the same in the early universe, leading to a lack of understanding of how stars form in this environment. These factors could lead to exciting discoveries that could overturn our understanding of star formation in the early universe. While this would challenge our current understanding, it would, in turn, open up new avenues for exploration and research. It's important to remain open to the possibility that our current understanding of the universe is limited and flawed. As we continue to research and explore the cosmos, we will undoubtedly encounter new and exciting mysteries that challenge our current understanding and change the course of science forever. The images that revealed these puzzling galaxies were obtained by Webb's Near-Infrared Camera, NIRCam, as part of the Cosmic Evolution Early Release Science (SEWERS) program. Astronomers plan to soon turn Webb's mirror to these galaxies again to, this time, obtain light spectra of those distant dots. Spectra break down the observed light according to its wavelength composition and thus reveal the chemical and physical properties of its source. The most important thing is that spectra give very precise distances to these objects, said Leha. The distance and the identity of these objects is correlated. If we know the distance, we can pin down the identity, and vice versa. So a spectrum will pretty immediately tell us if our hypotheses are correct. Only a little more than 6 months after the Webb team released the first observations from the Grand Observatory, scientists are already challenged to rewrite their theories about the early universe. The study of the universe and its evolution has been an area of fascination and curiosity for scientists and researchers around the world. The more we explore and learn about the cosmos, the more we realize how vast and complex it truly is. However, recent research has created some unexpected problems in the field of science, particularly concerning early galaxy formation. Emily Leha, an astrophysicist at the University of Arizona, and her team recently looked into the very early universe for the first time, and they were not prepared for what they discovered. In a Penn University statement, Leha expressed her surprise, stating, "We looked into the very early universe for the first time and had no idea what we were going to find. It turns out we found something so unexpected it actually creates problems for science. It calls the whole picture of early galaxy formation into question." So, what did Leha and her team discover that has created such a stir in the scientific community? They found that some of the earliest galaxies in the universe have unexpectedly low masses. This is contrary to what was previously thought, where it was assumed that galaxies in the early universe would be much larger. This discovery presents a significant problem for researchers as it challenges our current understanding of how galaxies form and evolve in the early universe. The prevailing theory was that massive galaxies formed early on and then merged with others to form even larger galaxies. However, the discovery of low-mass galaxies challenges this theory, raising new questions on how galaxies form and evolve. Moreover, the discovery of low-mass galaxies in the early universe could impact our understanding of the universe's evolution as a whole. The first galaxies played a crucial role in the universe's formation and evolution as they helped ionize neutral gas and influenced the formation of stars and black holes. Therefore, understanding the formation and evolution of early galaxies is essential to understanding the universe's history. Leha's team's discovery highlights the importance of continued research in the field of astrophysics. As we explore and gather more information about the universe, we will undoubtedly encounter new and unexpected discoveries that challenge our current understanding. It may seem daunting, but these challenges are what drives science forward, leading to new discoveries and advancements in our understanding of the cosmos. In conclusion, Leha's unexpected discovery of low-mass galaxies challenges our current understanding of early galaxy formation and evolution. While this presents a challenge to researchers, it also presents an exciting opportunity to explore new avenues of research and discovery. As we continue to explore and learn about the universe, we remain committed to pushing the boundaries of science and uncovering the mysteries of the cosmos.